Hi everybody, this is Dr. Hamid with your Math 120 College Mathematics class. Today we'll talk about section 2.3 which is about Venn diagrams and set operations. Okay. In today's lecture, our main objectives are to understand the concept of universal set and the concept of Venn diagrams. Okay. In addition to that, we will also, talk about some basic operations, set operations such as union of sets, intersection of sets, complement of sets, and we'll, look at some examples where we will find union, intersection, and complement of different given sets here. Now, let's start this lecture, okay, with the introduction of a universal set. Okay. This is a very important concept in set theory. Okay, uh, since by definition, okay, all sets, every set is a collection of objects, things, or numbers. Okay, so all sets are considered to be a subset of a bigger set. Okay, and this bigger set is known as the universal set. Okay, we use a symbol U to represent universal sets here. Okay, now to give you an example of a universal set, suppose we are studying any of the following sets here. Okay, suppose we are studying set of math major students at USC Upstate, or we are studying set of English major students at Upstate, or Hispanic students or Asian students. Okay, for any of these sets under consideration, okay, um, set of all students of USC Upstate will be a good example of a universal set. Okay, now because it's a bigger set and all of the than all of the above. Okay, and it will be a good example. It can serve as the universal set for all those. Okay, now let's move on, okay, to Venn diagrams and the basics of Venn diagrams. As you already know, a universal set is a set that contains all elements under discussion. Okay, so it's a bigger set. Now, moving on to Venn diagrams. Venn diagrams were, first introduced by John Venn, which was he was a British mathematician, philosopher, logician. Did a lot of things. He introduced these Venn diagrams in around 1880. Okay, and these diagrams are used basically. Okay, these diagrams are used um, uh, to express visual relationship among different sets. Okay, and nowadays they are very popular in all fields of science because they make things so clear and easy to understand. Okay, um, now here is an example. This is one simple example of a Venn diagram. Okay, with one set only here. As you can see that the universal set U here uh, in the Venn diagram is represented by this rectangle here. Okay, uh, and our set of interest is this A set here. Okay, now subsets in any Venn diagram within a universal set are represented by circles. Okay, for example, this circle here A. Okay, this is a subset of a universal set. And another thing to remember is the size. Okay, the size of these circles does not matter. Okay, big or small, circular or oval shaped. Okay, it does not matter as long as it conveys the message what you're trying to convey. It will work fine. Okay, so this is a basic basic thing about a Venn diagram here. Now let's look at different situation, different scenarios for two sets in Venn diagram. Okay, now if we have two sets, we can have four different situations. Okay, for example, disjoint sets. Okay, we can have two sets that have nothing in common. Okay, two totally disjoint sets. For example, set of 10 apples, set of 10 oranges, so nothing in common. So how will we express this in Venn diagram? To express this set in a Venn diagram, okay, we will have a universal set U, and then we will have two circles which will not overlap at all. They will be set apart. This is set A, this is set B, so nothing in common. This is example of disjoint sets represented by a Venn diagram. Okay, now let's move on. Next one will be equal sets. Okay, suppose we want to express two sets in a Venn diagram and those sets are equal. So what does it mean? When we say the set is equal, it means that A is a subset of B and B is a subset of A. Okay, that will make them equal to each other. Now in Venn diagram, since everything is contained, A is contained in B and B is contained in A, that means both circles must overlap. Okay, overlap on each other. So A is basically equal to B. Okay, so both circles are sitting on top of each other. Okay, everything is common. In this one, nothing is common. In this one is everything is common. Both extreme situations we are considering here. Now let's look at a third situation, which is sort of moderate. Okay, which says that we want to express sets on a Venn diagram which has some common elements. Okay, when we say some common element, we mean at least one of them, at least one or more than one. Okay, elements are common. So when we have something common, these sets will overlap. Okay, something like this one here. So we have A, we have B, few things are common. So this overlapping region represents the common elements in both sets here. Okay, this is the most interesting and well studied type of situation here. The last one is when one set is bigger than the other one and the smaller set is contained in the bigger set. Okay, so proper subset in other ways. Also all elements of set A are elements of set B. Okay, so in this situation we will have this one, a universal set that is represented by a rectangle, and the set A is contained in set B here. Okay, so this is the fourth situation here. Okay, now let's look at one very important concept. You already saw a situation on the last slide where two sets were overlapping, okay, or intersect in a Venn diagram. That's what we call an intersection of a set. Okay, so the intersection of set A and set B is denoted by A intersection B. Okay, and it is the set of all elements that are common to both. Okay, and the intersection of the set, okay, intersection of the sets is denoted by this symbol here, this symbol which is sort of a reverse U, upside down U here. Okay, so this is called the intersection. Okay, so in set builder notation, we can express is that A intersection of B is equal to X, all X, such that X belongs to A and, okay, since it's common, so X must belong to A as well as it must belong to B. Okay, so this is in terms of a Venn diagram, if two sets overlap, okay, we will have some region which will be common to both. So this red region here, okay, this red region shows the intersection region. Okay, the elements common to both sets here. Okay, so we have set A, we have set B. Okay, and the intersection of the two, the common to the two, is given by this overlapping region here. Similarly, let's look at the union of two sets here. Okay, so if we have two sets A and B, then the union of set A and set B is denoted by A union B is the set of all elements that are either in A or B or in both. Okay, which in set builder notation, when we have, it will be given to us A union of B is equal to all X such that X belongs to A or X belongs to B. You want to compare it with the intersection. In the intersection, this OR was replaced by AND. Okay, if it's an intersection, this will be AND. Okay, if it's a union, this will be OR here. Okay, now to represent this thing in Venn diagram, Okay, the red shaded area here, it represents the union of two sets, which is basically the everything. Okay, so what do you do basically? To find the union of two sets, we will combine, you know, all members or elements, okay, and write a new set which will be the union. Okay, you do not have to repeat the elements. Okay, if both have 2 and 2, you do not need to write 2 twice, just once. Okay, do not repeat. For example, let's look at example here. A simple example in which we will calculate the intersection and union. This is one set. Set A is given to us, which has elements 1, 2, 3, 4, 5, and set B has 1, 3, 4, and 6. Okay, our goal is to find A intersection of B first. Okay, and also, represent on a Venn diagram. Don't worry about the Venn diagram. Let's focus on this one here first. So to find A intersection of B, okay, it comes out to be, we are looking for elements common to the both. Okay, so what are we looking for? We are looking for what is common. 1 is common, so goes into the intersection. 3 is common, goes into the intersection, and 4 is common, goes into the intersection. There is nothing else which is common to both. Okay, so this is your A intersection of B. Now to find A union of B, okay, as I told you earlier, we are combining all the elements in A and B without avoiding repetition. Okay, so do not repeat the elements. So we have, 1, 2, 3, 4, 5 in this one. Okay, so 1, 3, 4 already in this one, so include 6. This is your union, A union of B. Okay, now let's look at a Venn diagram here. These are two sets given to us, set 1, set A, set B. Okay, now intersection will be, this one, the overlapping part will be given by this region here, this set 1, 3, 4. Similarly, if you want to have the union, it will be the, the whole thing here. Now the next big thing in this section, and very important thing, is known as a complement of a set. Okay, so suppose we have a universal set given to us, which is U, represented by U, and our set of interest is A, which is a subset of a universal set. Okay. The complement of set A, we will denote it by A prime. Okay, it is given to us as the set of all elements in U that are not in A. Okay, so elements in U that are not in A. So we want to, from U, we will exclude all the elements that are in A here. Okay, so in set builder notation, we are looking for all those, to find a complement, we are looking for all those X such that X belongs to the universal set, and at the same time X do not belong to the set A. Okay, and this is also represented by, the difference here. I don't think we will use this notation in our book, but some books use that, so I tried to put it up there. Okay, now as a in terms of a Venn diagram, if this is a set A, okay, and we want to find a complement of it, it will be everything but this set here. So the complement is all this blue region here, that is A prime, complement of A. Okay, look at example here. Suppose we have universal set given to us A, B, C, D, E, F. A is A, C, E, B is B, D, E, F. Okay, we have to find the following. Okay, first thing is we have to find A intersection of B and then the complement of that. You understand me? A intersection of B and then the complement of that. Okay, so we'll do it in step by step. Let's first find the A intersection of B. Okay, elements common to both A and B. So this is A, this is B. What is common? A is in this one, not in this one. C is this one, not in this one. E is the common one. Okay, so let's write E. So this one, this is our A intersection of B here. Okay, which comes out to be E. Now let's go on to what we want to find. A intersection B and complement. Okay, so what do we want to do? We want to find those elements that are in U but not in A intersection B. So we will exclude this element from U. That will be our complement. So exclude E from this set here everything remaining will be the complement. A intersection B complement. This is our answer right there. Now, next thing is, let's find A union of B and then complement of that. Okay. So to do that, again, we will do work in steps. Let's first find A union of B. Okay. And A union of B is combine all the elements of A and B, and we get this set here without repeating elements. Okay. Now we want to find the complement of this. What does it mean? Complement of this will be, exclude these elements, all these elements from the universal set. But the problem is, it is same. Okay, this one is same. So if we exclude all these from U, we will be left with the empty set. Okay, so A union B complement will be an empty set here. So this is our answer. Okay. Now this is sort of a conceptual thing. This is about the role of empty set in intersection and union. So if we have any given set A, okay, then if we take the intersection of A with the empty set, okay, this phi here or phi here is the empty set here, okay, A intersection with something which has nothing will have nothing in common. Okay, so A intersection of empty set is just an empty set. Now if we add empty set to A, it will just be A. Okay, we will not be able to add anything into that one. Okay, so these are sort of conceptual thing. I think I included a couple of problems related to that in your homeworks. That's why I included this slide here. Now let's look at a few more examples which are similar to our homework problems I assigned to you and quizzes. Okay, let's see. Universal set is given to you, A is given to you. Our goal is find the complement. Okay, now we know that to find the complement, what we want to do is we want to exclude the elements of A from U. Whatever is left over, that will be your complement. Okay, set A prime contains all elements of set U that are not in set A. Okay, as I said, in simple words, exclude the elements of the set from the universal set. Okay, so set A contains elements 1, 3, 4, 7. These elements cannot be member of A complement. So A complement will be whatever is left over, which is 2, 5, 6, 8, and 9. That's your answer. Okay. Now let's look at example 2 here. In example 2, we want to find the intersection of two sets. Okay, and the sets are given to us as 7, 8, 9, 10, 11, and set B is 6, 8, 10, and 12. We want to find the intersection, the common of the two. Okay, the common of the two is 8, the common of the two is 10. That's it. Okay, so to find A intersection B, it will just be 8 and 10. Done. Okay. Second example is, suppose we have this is our A, set A, this is our set B. Find A intersection B again. Okay, so this time nothing is common. You see that 1 is not in there, 3 is not in there, 5 is not in there, 7 is not in there, 9 is not in there, so nothing is common. A intersection of B is just an empty set. Okay. Third example is, suppose we want to find the intersection of this set, okay, with the empty set. I told you when we are finding the intersection, there is nothing in common, so it will be an empty set. Okay, so sort of a few conceptual ideas right there as well. I included many problems like this one. I want you to do this problem. They will just take seconds. Okay. Let's look at one example where we have to find the union of sets. Okay, suppose two sets are given to us. A is given to us like this one, 7, 8, 9, 10, 11. B is 6, 8, 10, 12. Let's find A union of B. A union of B will be, we'll combine all these elements, okay, without repeating. It comes out to be A union of B, 6, 7, 8, 9, 10, 11, 12, all those elements. Similarly, if this is set C, this is set D here, okay, if you want to find the union, just combine the elements without repeating. This is this one here. And the last example is, this set is given to us, same set, and we want to find its union with empty set. Empty set contains nothing, so nothing to combine. It will be the original set as it is. Okay, like that. Um, let's look at fourth example, in which we will be performing some set operations. And if we have moved them more than one operations, okay, we are finding bunch of things. Always perform operations from inside outwards. Okay, start with the innermost thing and then work your way outwards. For example, this is a set given to you. U is this universal set. A has this elements, B has these elements, and our goal is to find A union B intersection and A intersection A union B complement and A complement intersection B complement. So let's do them one by one. To find A union B complement, so first find A union of B, which is A union of B will be combining these two. It is 1, 3, 7, 8, 9, 10. Now you want to find the complement of this. That means exclude these from the universal and remaining will be your answer. Okay, so complement will come out to be 2, 4, 5, 6. Okay, done with the first part here. Now let's look at A complement intersection B complement. So first we have to find A complement, then find B complement, and then find if they have anything in common. A complement is this, B complement is this. Do they have anything common? Yes, they have 2 common, 4 common, 5 common, 6 common. Put them out. 2, 4, 5, 6. That is your final answer. Okay, I hope you're getting the idea. Now let's look at how to find information from the Venn diagram. Okay, so to get the information from Venn diagram, this table here, it shows what we want to find, and the description of the set and which regions it will consist of from the Venn diagram. For example, if you want to find A union B, okay, A union B will be the set of elements in A, B, or both. So this will basically be all elements here, all regions 1, 2, 3. Okay, so the region in Venn diagram will be 1, 2, 3 in A intersection of B. Okay, if you want to find A union B, okay, and then the complement of that. So this one will be set of elements in U that are not in A union of B. Okay, or in other words, we will first find A union of B and then we will exclude these from the universal set. So what will be the leftover? Leftover will be region 4 here. Suppose we want to find the intersection of A with B. That will be this overlapping region here. Okay, so that will be region 2 here, the simplest and easiest one. Suppose we want to find A intersection B complement. Okay, so this will be the set of elements in U that are not in A intersection B. Okay, so from Venn diagram, it will be regions 1, 3, and 4. Okay, we are excluding this part only. We will exclude this part, and everything else will be the region. Okay, now suppose we have A complement intersection B, so set of elements that are not in A and are in B. Okay, so that will be region 3 here. Similarly, if you want to find A intersection, A union B intersection, so we are looking for set of elements that are in A, are not in B, or both. So that will be excluding, basically we are excluding the set B. So we're excluding this region. Everything else will be part of this set. Okay. Now this is an important thing. How to find a cardinal number of a union of two sets. Okay, we know how to find a cardinal number of individual set. Just count the number of sets. But suppose we want to find, uh, without finding the union, we have a set A, set B, and can we tell what will be the union? What will be the cardinal number of the union? Okay, so cardinal number of the union of A union B is equal to cardinal number of A plus cardinal number of B minus the cardinal number of intersection A intersection B. Okay, this will give us the cardinal number of the union. So again, let's look at survey result, a blood drive survey. It showed that 490 students were willing to donate blood. Okay, it showed that 390 students were willing to help serve a free breakfast. Okay, so this is n of a, this is n of b. Okay, it was also given to us that 120 students were willing to do both. So that will be the intersection of these two. Okay, and intersection. So we have this, we have this, we have this. Okay, now can we find out uh, how many students were willing to donate blood or serve breakfast? Okay, so they were willing to do both. So basically what we have to do, we have to find, the cardinal number or the number of elements in A union B here. Okay, so this is what we want to find. Okay, same slide from there. This is what it looks like with the Venn diagram. Okay, we're not interested in that, but this is what we are interested. We want to apply this formula here. We know n of A goes here, we know n of B goes here. Okay, we know n of intersection B goes here. You work this out. So people who, on those number of students who are willing to do both, are 710. Okay, we found it using a simple formula. So this is called the cardinal number of union of two sets. Okay, thank you very much. This was sort of an easy section in which we talked about set operations and Venn diagrams for two sets here. Okay, in the next section we'll talk about the same things for three sets. You will see that. Okay, please try the homework assigned to you in my math lab. If you have problems, if you get stuck, if you need help, please contact me and I will help you. Thank you very much. Take care. Bye bye.